Now we focus on the principles of ultrasonic microscope. And the objective being tested is a chip which we place in water during the inspection. The water here the water acts as a coupling agent. But why do we need a coupling agent here? As we all know, although ultrasound can propagate through air, the significant difference in acoustic impedance between air and object being tested, such as metal or human tissue, causes most of the ultrasound to be reflected, making it difficult for the waves to effectively penetrate the sample. Therefore, in practical applications, we often use a water as a coupling agent to reduce interface reflection and improve the penetration efficiency of the ultrasound. For example, in medical ultrasound, the transparent gel applied to the abdomen, as known as B-mode ultrasound, is also a coupling agent. And industry inspection, water is commonly used as a coupling agent. And we can say this image illustrates a diagram of ultrasonic testing. Probe. A probe is located above the sample, emitting ultrasound waves that strike the sample. The ultrasound waves will reflect it and transmit at each material interface. We can say here are four reflections. First reflection, second reflection, third reflection, and fourth reflection. For the first reflection and the interface between water and plastic encapsulation. The second reflection and the interface between plastic encapsulation and the chip. The third reflection at the interface between chip or die and the lead frame. And the last reflection at the interface between lead frame and the water. The reflected waves are receiving by the probe also. At the bottom, we also install receiving probe to receive the ultrasound signals that pass through the plastic encapsulation and the chip. By collecting and analyzing these signals, and we form a waveform just like this, with each interface corresponding to a significant wave. So there are altogether four reflection and its corresponding. First, black signal. Second, white. Third, purple. And last, blue. And the probe performs an S-shape scan at each position. We receive such a waveform. Next, we extract the character value as all the received waves, such as amplitude height, time interval between first signal, second signal, or second signal and third signal, or phase. It means positive phase or negative phase. By extracting these characteristic values, so we can form a grayscale or color scale just like these two images. So this is the basic principle of ultrasonic testing.